Hi there. I'm going to present a semantic data model today. For doing so, I have chosen airport data as an example. This can be obtained from website rairports.com/data, as you can see over here. I have several CSV files over here. So this is the data set which I'm using. Airport.csv, airportfrequencies.csv, then runways, navigation IDs, country, regions. So let me just open up one of these CSV files and show you how it looks like. So this is my airport.csv file. Here I have the airport ID, airport identity, GPS code. I have latitude, longitude. Similarly, if I open up the countries.csv file, over here I have the country code, country name, continent, and using this I'm gonna model my ontology. So this has since this has so many fields, this just motivated me to choose the data set to create the web ontology using Prodigy. So let me just open up Prodigy for you. So as you can see, these are the classes which I have chosen for my ontology: airport, country, location, radio navigation, region, runway. I have created some object and data properties for this. If I go to properties and show you the object properties, belongs to, the domain is airport and its range is country. Similarly, I have has airport. This is having country as my domain and airport as the range. This is basically inverse functional. I have similar object properties called has location, has region, has runway, is present in region, is region of, operates with navigation. So let me show you some of the data type properties which I've chosen. I have chosen for airport class, I have airport ID, airport name, airport type, and airport reference. And as I have for country class, I have continent, country code, then the country ID, country name. So for each and every class, I have different data properties and object properties. And to mention, each of these classes are disjoint. So airport is disjoint from region, country, location, radio navigation, and runway. Now let me show you the instances that I've created. So for the airport, if I go to individuals and check the instances, over here you can see airport 1, 2, 3, all these are different instances which I've created. Over here I have airport ID, so 6523, which is of integer type, then frequency 122.9, which is a float, then I have airport name whose value is total RF heliport, and it has a GPS code of 00A. So the object properties which it has are like has location, so it is associated to location 1. Has runway, it has runway 1, country 1. So let me just take a quick look at what is there in country 1. If I open up the instance for country 1, you can see that the country code is US and the country ID is 302755, and the value, the country name is United States. So this is how I have my instances. I have created many instances for each of these classes so that I can query on these and For doing so, I have used Sparkle query language to query the modeled ontology. I have written a simple Java program for querying the ontology and displaying the results on the console. Let me just quickly open up Eclipse and show you what I have here. So in my project, I have this OWL file which has my complete data set, the ontology basically. So this ontology is being queried from my program. I will show you what kind of queries I've written. So over here, to list all airports present in US, I have used this query. So this is basically select distinct name where airport, RDF type, base is the airport, and so I have taken the airport name and which country it belongs to and the country code. I'm just filtering it by the country the code, that is US. So it lists me all the airports that are present in US. I have used 5 queries over here. The second query is list all airports in the descending order of their runway lengths. So I have used an order by in descending order over here. Then I have another query which is list all medium-sized airports operating at a frequency higher than 120. So here basically I have used a filter which gets me all the frequencies that have all the airports with frequencies operating at more than 120, and then the type is medium airport. Then I have a query which is list total number of airports in each country and the country's maximum frequency. For this one, I have used a group by function, which is on the name, airport name. Then I have also used aggregate functions like average, and you can see max and count, which are also being used. So let me run this program and show you what kind of results I get. Okay, so this is my console. So you can see what the first query fetched me. All the airports in US. I got total RF heliport, Knox Army heliport, and Lowell Field. If I go to my ontology and quickly see which are the airports that are in US, my country is US is country 1. So you can see in airport 1 has country 1, and then airport 2 has country 1, and airport 4 has country 1. So those 3 are listed. Okay, so in the similar way, any data on the web can be modeled in using the semantic web to visualize the data in a meaningful way. This is the future of semantic web, and there is a lot more to be explored. So this is what I learned from this class, the semantic web class, and that would be the end of it. Thank you for patiently listening to me.